Can't remember where we left off here. So, start from the top. Okay, let's clean up the top. So the top of this fraction, exponents. So there's a couple rules. No negative exponents. You gotta know when to add exponents and when to times exponents. When you're timesing letters, you add the exponents, but when you're raising an exponent to another level, that's when you times them. So if you know when to times them and when to add them, you're in pretty good shape. So on top, you are going to times the 2 with the 4, and that makes 8. Okay, now your x's, you're going to times these x's with these, but you only have 1 here and you got 2 there. So it's x to the 2 plus 1. And your y's, you're going to have y to the 3 plus 4. So that's when you add them. Okay, now on the bottom, it's 3 times y squared. These x's, take these to the top. So when you move it to the top, it becomes positive. So it's going to be a positive 3. So these 3x's, I'm going to add in with these guys right here. Okay, so I'm going to erase that. So on top, you should end up with 8x, 2, 3, 4, 5, 6, and y to the 7. Then on the bottom, you got a 3 and y squared. Okay, now the y's are going to play together. 2 of these y's on the bottom are going to undo 2 of the y's on top. So your final answer is you got 8x to the 6, y to the 5, and then on the bottom you got 3. And that's it. Okay, the next chunk, rational exponents. So, here's the big deal, morphing back and forth. If you come across an exponent that is a fraction, you morph it to a radical. So if you ever have an exponent that's a fraction, you morph it to a radical. Okay, now this 2 goes right here. And this 1 goes right here. So that's 1. And then this 2 goes right here. So there's 3 pieces. You got to put that piece there, that piece there, and that piece there. So you can morph back and forth. So if you have a radical that has like 5 to the 6 and 3, this piece, this piece, this piece, if you morph it to an exponent that's a fraction, the base will be 5 and the 3 will be the numerator and the 6 will be the denominator. So here we go. You've got the square root of 8 to the 1/3. Now let's morph this. There is a 1 there, and if there is no number here, it's 2. It's a square root. It's understood to be 2. So if you morph this right here, that changes to 8 to the 1/2. So I'm going to morph it from a radical to an exponent that's a fraction. And 8 to the 1/2 to the 1/3. And now your properties of exponents apply. So if you have an exponent and you're taking it to another level, you times them. So this is 8 to the 1/2 times 1/3. And timesing fractions is pretty easy. Just times your tops and times your bottoms. So it's going to be 8 to the 1/6. Okay, now if you morph that back, the fraction says it's going to be some radical. The 8 is the base, it goes there. 1 goes there, and 6, so it's a 6th root. So 6th roots only undo powers of 6, and that matches up with C, the 6th root of 8. Okay, this guy right here, it's just exponents. Now you got to distribute the 2. You got to take the 2 to everything. Take it to that 2, take it to the x, take it to the y. So you're going to have x times y squared times 2 squared, you times them. So the exponent of the 2 is 1. So it's really 2 times 1. Now the exponent of the x is 3 times it by 2, so x to the 6. And y to the negative 1 times 2 is going to be negative 2. Okay, now move number 2. I'm going to do the number first. So 2 squared is 4. That's done. Do your x's. You got x1 and x6, so it is x1 plus 6. And do your y's next. So it's going to be times y2 plus negative 2. So you end up with 4x to the 7th, and that is it, because your y's, that's a 0, so your y's are gone. A says place one number. So here's your numbers you can choose from. You drag and drop. Place a number in each box so that the simplified expression will be an integer. Simplify the expression in part A. Place one number in the box to show which integer you have created. So if you take 9 and put it there, and you drag and drop 2 there, that is 9 to the 1/2. If you morph that, instead of being an exponent that's a fraction, if you morph it to a radical, the 9 goes here, and the 1 goes here, and the 2 goes here. So it's asking you to do the square root of 9. And the square root of 9 is 3 times 3. So the square root of 9 is 3 squared. So that square root is going to undo the square, and the integer it creates is 3. So 9 to the 1/2 is the exact same thing as the square root. So the only other one that'll work is if you drag and drop 4 to the 1/2. There's one more that'll work. So 4 to the 1/2 is the same thing as square root of 4, and square root of 4 is 2. Okay, the other one that'll work, the last one that'll work, is if you do 8 to the 1/3. Okay, now 8 to the 1/3 is going to morph to the radical of 8, 1, and it's cube. So it's cube root of 8. And 8 will break down into 4 times 2. 4 breaks down to 2 times 2. So here's what it breaks down to: the cube root of 2 cubed. And the cube is going to undo the cube. Cube roots undo cubes. So if you put 8 to the 1/3 up here, the integer it creates is also a 2. So you have 3 different options. Okay, kind of a similar type of problem. Drag and drop the numbers to make them true. So the square root of 16, okay, square root of 16, that just equals 4. So you have got to drag and drop 1. Okay, now this one is a tough one. 64 busted up. Always break the numbers up. So 64 is 8 times 8, and 8 is 4 times 2. And 4 is 2 times 2. So if you break up 64, 64 is the same thing as 2, and you have got 6 of them. Alright. So I might be making this a little more complicated than I need to. You got to put a number here. If you put a 6 here, so if I put a 6 there, so the 6th root, because I got 6 2's, a 6th root is going to undo that power of 6. So that would just leave me with 2. Your answer is 2. So you'd have to put a 1 here, and that would be true. Okay, now here's what else you know. Square root of 64, that just equals 8. because that's a perfect square. So you could also you could do 6 and 1. That would work. Or you could drag and drop the 2 and make a square root, and the square root of 64 is 8, and 2 cubed is 8. So 2 times 2 times 2 would be 8. So that would work. So one of those would work. Okay, now the bottom one. So there's more than one right answer. The bottom one, the 4th root, okay, bust up 27. 27 is 9 times 3. That's prime. 9 is 3 times 3. So here's what it breaks up to be. 4th root of 3 cubed. Now this one, there's only one right answer. If you morph it, it will turn into 3 to the 3/4. 3 to the 3/4. Okay. Select all the expressions that are equivalent to 4 to the 3/2. So it didn't copy very well. That's 4 to the 3/2. Okay, now 4 to the 3/2. Let's go box by box. You're going to times the exponents. So if you have an exponent to another level, you got to times it. So this is 4 to the 2 times 1/3. Make 2 a fraction, times your tops, times your bottoms. That's the same thing as 4 to the 2/3. And we're looking for 4 to the 3/2, so that one is a no. Same thing, make that a fraction, times your tops, times your bottoms, so that's 4 to the 3/2. That one is a yes. Morph this. If you morph this, it will morph into 4 to the 2/3, and we're looking for 3/2, so that's a no. If you morph this, it's the same. The 4 goes here, that 3 goes on the bottom, and that exponent goes on the top. 4 to the 2/3, that's a no. 8 is actually a yes. And here's why. Okay, if you morph this into a radical, the 4 will go here, and the 2 will go here, and the 3 will go here. And 4 cubed is 4 times 4 times 4, which is 64. And that's the square root of 64. And the square root of 64 is the number 8. So 8 is what it cleans up to be. Okay, now this is a radical. Morph it to an exponent. So it's going to be 4. That's a 2. So it is 4 to the 3/2. That one is a yes. Times your tops, times your bottoms. So that one is 4 to the 3/2. That one's a yes. That's a 2. That's 4 to the 3/2. That one is a yes. Times your tops, make this one a fraction, times your tops, times your bottoms. That one is 4 to the 2/3. So that one is a no. Okay, imaginary numbers, complex numbers. What is the standard expression of a complex number? So a complex is a real and an imaginary. So the real part is 5, and the imaginary part is a -3. So how you tell it's imaginary is you put a little I. So you're going to combine them together. It's got to be this. The real number always comes first, and then the imaginary comes second. So that has to be D. That's got to match up with D. Okay, evaluate. So clean this up and then drag and drop these numbers into the right boxes. So this is times. You got to times this to this. 3i times 2 is 6i, and the only thing you need to remember with imaginaries is if you have an imaginary times another imaginary, it turns into a real, and it turns into a -1. Imaginary times imaginary is always going to give you negative 1. Now times this to a negative 7i. So times the numbers. 3 times a minus 7 is a minus 21. And then times imaginary times imaginary is imaginary squared. Or I times I is real. It turns to a negative 1. So it's really negative 21 times a real negative 1. And a negative 21 times a negative 1 is a positive 21. So I got 6 imaginaries and I got positive 21 reals plus 4 imaginaries. So your imaginaries are like terms, they're going to play together. 6 imaginaries and 4 imaginaries, that's going to be 10 imaginaries and 21 reals. So 21 reals plus 10 imaginaries. So you need to drag and drop the 2 there, the 1 there, the plus there, the 1 there, the 0 there. 21 reals plus 10 imaginaries. Okay, you got 2 problems. So select all the expressions that are the same as 4 imaginaries. Okay, the top one is a minus. So plus and minus, you can only plus and minus like terms. So it's really the 3 reals minus 3 reals, and that is 0. So now you got to do 2 imaginaries minus the 2 imaginaries, and that is also 0, so it's not that one. 2 imaginaries squared, you got to take this exponent to both. That's 2 imaginaries times 2 imaginaries, and the 2 times the 2 is 4, and I times I is a negative. So that's a negative 4 times I cubed. So that's like I times I times I. Okay, I times I is a negative. So you got a negative 4 times a negative 1 times I. And a negative 4 times negative 4 is a positive 4i. So that one is a yes. Okay. So we got this one, yes. Now another minus problem. So 2 reals minus 2 reals, that's 0. 2 imaginaries minus a negative 2 imaginaries, and that is minus minus is a plus. That's 4 imaginaries. That one is a yes. Okay, your third one is a times. 2 times 2 is 4. Plus 2 times the imaginary is 2 imaginaries. So 4 reals plus 2 imaginaries. That one is a no. And then the bottom one, you got to times the 1 times 2. That's 2. 1 times 2i. That's 2i. I times 2. That's 2i. I times 2i. That's plus 2i squared, and that is a negative. So 2 times a negative is a negative 2. So the negative 2 plays with the positive 2, and that is a 0, and your imaginaries play together. 2 imaginaries and 2 imaginaries, that is 4 imaginaries. So that one is a yes. So it was these 3 are all yeses. Okay, multiply. You've got to distribute. You've got to times the 3 to the minus 4, and that is a minus 12. Then you got to times the 3 to the 5i, and that is 15i. Then you got to times the negative 2i to a negative 4. Then you don't forget the negatives. Negative 2 times negative 4 is a positive 8i. Then the negative 2i to 5i, and negative 2 times 5 is a negative 10, and I times I is a negative, so that negative is going to turn that 10 into a positive 10. And the positive 10 plays with the negative 12, so negative 12 and a positive 10 is a negative 2, and 15 imaginaries plus 8 imaginaries, they play together. And that is 23 imaginaries, so that one matches up with A. Okay, now factoring. Turn these into times problems. So you gotta have your factoring paper to look at. So here's what you're looking for. You are looking for the numbers that times and give you 36. Okay, so they multiply and give you 36, but they add to give you the middle. So if you start looking at the factors of 36, you got 5 to choose from. You can choose 1 and 36, you can choose 2 and 18, you can choose 3 and 12, 4 and 9, or 6 and 6. So choose the ones that will add to give you the middle. The middle tells you which one to choose. So you got to add and give 13. And that's going to be the 9 and the 4. And everything is positive, so that's the easiest type. Because if everything is positive, it's got to times and give you a positive, it's got to add and give you a positive. So it's going to be a plus 4 and a plus 9. Okay, this one's also easy. So it's got to times, so you turn it into the two factors. It times to give you x squared, so that's x and x. Times is to give you 20. So here's your choices for 20. 20, you can use 1 and 20, 2 and 10, or 4 and 5. And you're looking for the pair that will add and give a 12. So you're going to go 2 and 10. So plus 2 plus 10. Because those will add and give you 12, but they'll times and give you 20. Okay, now let's do the ones that are going to be harder, because negatives start showing up. Okay, so x and x. Here's what you know. It's got a times to give you a positive. The only way you can times and get a positive is by a plus times a plus or a minus times a minus. And I know it has to be a minus times a minus because it will add to give you a negative. So 50. One of them, let's see, 50, they're both negatives. Here's your options for 50. You've got three options. You got 1 and 50, you got 2 and 25, and you got 5 and 10. Okay, which ones can make 15 negatives? You're going to go with the 5 and 10. Because a minus 5 minus 10 equals minus 15, but a minus 5 times a minus 10 equals a positive 50. So a minus 5 and a minus 10. Okay, the bottom one. Here we go. You're going to times k by k to create the k squared. And okay, the 32 is negative. The only way you can create a 32 negative is if one of them's plus, one of them's minus. Okay, 32, you got a lot of options for 32. Actually, you don't. You got 1 and 32, you got 2 and 16, and you got 4 and 8. Okay, one is a plus and one is a minus. And you've got to create a minus 4. And you're going to go with that. So here's your options. It's either 8 minus 4 or it's 4 minus 8. 8 minus 4 equals 4. 4 minus 8 equals a minus 4. And that's what you want. So the 4 has got to be the positive and the 8 has got to be the minus. And that's how it's got to be. So factoring, just turn them into times problems. Okay, now solving equations. Solving equations, we know because the exponent is 2, there's going to be 2 solutions. Okay, now, if you've got v's and v's, the best way is to factor it. So if you've got v squared and you got 9v, you don't know which v to solve for, because you want to solve for v, you want to get rid of everything else, but you don't know which one to solve for, so factor it. If you can turn it into a times problem, then it's going to be a million times easier. So what numbers times and give you 18 and add and give you 9? So 18, you got 1 and 18, you got 2 and 9, you got 3 and 6. So they got to times and give 18, but they got to add and give 9. Those are your numbers. Everything is positive, so it's v plus 3 times v plus 6. Okay, now look at it like this. If you look at it like this, it's going to be way easier to find an answer. So here's what you got. You've got something times something equals 0. That means either this is the 0 or this is the 0, or maybe they're both 0, because the only way you can times and get 0 for an answer is if you're timesing by 0. So now you're asking, okay, v, what can I put in place of v to create this guy to be 0? And it is a minus 3. If you take v out and you put a minus 3 here, so you got to put a minus 3 for both of these, and a minus 3 there. Minus 3 plus 3 is 0. And a minus 3 plus 6 is 3. And 0 times 3 does equal 0. So minus 3 works. But I know because it's a quadratic, there's going to be 2 solutions. So that's one of them. Or the other solution, let's make this guy be the 0. So what can I put in place of here? So it was v plus 6. What can I put in place of v to make a 0? And that would be a minus 6. Because a minus 6 plus 6 would make that 0. So these are your two answers. V can be a minus 3 or it can be a minus 6. Okay, same thing. Look at this as a times problem. So factor it. Change it to a times problem. What will times and give you x squared, x and x? What times is to give 4, but adds to give 5, and that is 4 and 1. And everything's positive. The only way you can times and end up at 0 for an answer is if you're timesing by 0. So one of these has to be 0, or both of them. So what would make the first group a 0? Minus 4 would. What would make the second group a 0? A minus 1 would. So those are the two solutions. You know you're going to have two solutions because the exponent's 2. Okay. Radicals. You're solving for x, and since there's only one x to solve for, that's easy. Exponent's 1, so there's going to be one solution. So start undoing everything. Undo the minus 4. Plus 4, plus 4. Undo anything outside the radical first. So you should have 10. Now you got 13x minus 4, but the 13x minus 4 is trapped underneath the radical. So you've got to undo the radical. You got to lift this square root off. The only way to undo a square root is to square it. So you're going to square this, and you got to square this. So the square undoes the square root. So you got 13x minus 4, and 10 squared is 100. Okay, now undo the times or the minus. Undo the minus first. Plus 4, plus 4. So you got 13 times x equals 104. Undo the times, so divide by 13, divide by 13. So that undoes, and you've got x equals 104, divide 13. And that one solution is 8. Okay, this guy right here, undo this minus 6, but it's minus 6 times. So undo the times actually. So you're dividing by minus 6, divide by minus 6. So you should have a positive 2 equals the square root of b plus 2. Now you got to get to the b plus 2, so you got to square it, and you should have 4 equals b plus 2. Undo the plus 2, minus 2, minus 2. You should end up with b is equal to 2.